Good morning and good afternoon. Welcome to ARA's Webinar Wednesday. I am Sri Rao, your moderator for today's webinar titled Developing a Pavement Marking Management System, North Texas Tollway Authority Case Study. Now, I'd like to introduce our presenter, my colleague and friend, Leela Shushita Chinnakotla. Leela is a staff civil engineer, 2 at ARA Applied Research Associates, and she holds a master's degree in civil engineering from Texas A&M University, specializing in pavement materials, and is an engineer in training, certified by the Texas Board of Professional Engineers. Since joining ARA in 2021, Ms. Chinnakotla has contributed extensively to pavement marking research and management projects, helping over 8 transportation agencies achieve their safety goals. So you're in good hands with Leela in terms of the knowledge and information that you're going to get with pavement markings. Leela, really appreciate you presenting at Webinar Wednesday, and I'm going to hand it over to you. Thank you.
Good morning, everyone. This is Leela Chinnakotla. Today, I'll be discussing the pavement marking management services that ARA has provided to North Texas Tollway Authority over the past 3 years. I'll start this presentation with an introduction to the importance of pavement markings, pavement marking testing concepts, and FHWA minimum retroreflectivity guidelines. And then we'll move into the project specifics in yearly manner. And I'll conclude the presentation by highlighting the key takeaways from the project. So, why are pavement markings important? In a single line, pavement markings serve as the language of roadways. They enhance roadway safety, especially during nights. Research shows that the nighttime fatality rate is 3 to 4 times higher than that of daytime due to various reasons like reduced visibility, impaired driving, and fatigue. And an effective way to address this reduced visibility is having good in service markings. And pavement markings also, especially, are important for meeting older drivers' need with declining visual capabilities. Secondly, these markings help organize traffic by clearly indicating the lane assignments and guiding vehicular movement. And in recent years, the importance has grown even further with the rise of advanced driver assistance systems and automated driving systems, which often rely on markings for lane detection and vehicle control. So, how do we determine whether a pavement marking is performing well? That is through a concept called retroreflectivity. Retroreflectivity is a measure of object's ability to reflect light back towards its source along the same axis from which it strikes the object. So in the context of pavement markings, it is the amount of light from vehicle headlights that is striking the marking and is reflected back to driver's eye. The coefficient of retroreflected luminance, short formed as RL, you'll hear this term a lot along to this entire presentation. It's a metric to quantitatively measure the retroreflectivity of pavement markings using a 30-meter geometry as illustrated in the image here. The units of this RL are millicandles per square meter per lux. So the higher the RL, brighter are the markings. And markings are made retroreflective by partially embedding optical elements like beads into marking materials such as like paint, thermoplastic, epoxy, tape, etc. When the light from the vehicle headlights strike these beads, they reflect, and again refract back, directing the light source to the driver. So maintaining this pavement marking retroreflectivity to a level that meets the nighttime driver needs is consistent with the Federal Highway Administration's goal of improving safety on the nation's streets and highways. On August 5th, 2022, the FHWA published a final rule updating the MUTCD to include minimum retroreflectivity standards for pavement markings. As per the standard, the agencies shall conform to a method designed to maintain minimum retroreflectivity of 50 millicandles per meter square per lux in dry conditions on all longitudinal markings on any roadway with speed limit of 35 miles per hour or greater. And according to the guidance, the agencies should conform to a method designed to maintain an RL of at or above 100 in dry conditions on all longitudinal markings of any roadway with a speed limit of 70 miles per hour or greater. So, how do we know that a marking is reflecting and giving so and so number of RL? So that is some measurements, and we can do the retroreflectivity measurement using retroreflectometers. An ASTM standard E1710 provides standardized guidance for measuring the retroreflectivity of the markings using the retroreflectometer. And several manufacturers offer the retroreflectivity testing equipment, but the devices shown here are what ARA currently owns and uses. The first one is a Delta LTL 3500. It's a handheld retroreflectometer, and it uses LED lights to measure the retroreflectivity. Units are most suited for localized assessments or quality control checks, while the one on the right side is a mobile retroreflectometer unit. This one is a LLG7 unit by Gamma. This uses a laser diode beam with 1 meter sweep for the measurements, and this unit can be attached to any vehicle and driven at traffic speeds, and it can collect around 400 RL measurements per second. And both these units follow the geometry requirements that you saw before through scaled versions. So, having covered the basics of retroreflectivity and the testing, I'll now walk you through the project and how we applied these for developing a pavement marking management system for NTTA. And I would like to take a moment to acknowledge our prime, VRX. So VRX is the general engineering consultant for NTTA, and we served as a sub in this project, performing the testing and analysis for NTTA since 2022. NTTA network consists of 5 toll roads, 2 bridges, and 1 tunnel, as you can see in the map here. In total, they have around 1,800 line miles of longitudinal markings on the main lanes, frontage roads, and direct connectors that we tested. Also, they primarily used 3 marking types on their roadways, which were prefabricated tape, thermoplastic, and all-weathered pattern thermoplastic. And we evaluated all 3 marking types in this project. The main goals of this project were to identify the maintenance striping needs, identify the optimum pavement marking material for the roadway environment and their maintenance budget, and to determine the marking materials service lives. For this, in year one, we started with establishing framework. So we finalized a nomenclature to identify each testing line. So each line is named with the facility a name, the posted travel direction, and line designation. Here, LEL and REL are left edge line and right edge line respectively, and SL1 and SL2 are skip lines 1 and 2 from left to right. Next, we worked with NTTA to define the condition rating scale and to evaluate the pavement marking performance. And just that the timing of this project was falling just around the time when FHWA released the final rule. So we were able to incorporate the MUTCD guidelines as our low threshold. And these other three categories were assigned to see which markings might need maintenance at much later time, and this transitional zone was kept as a short period of time where they could make arrangements for replacing or the markings or for their other maintenance needs. And there were a few roadways in this network where the speed limit was less than 70 miles per hour, but we still maintained the low threshold at 100 across the network for safety and consistency. After fixing that, we went ahead with the data collection and processing, and these steps are show each of the process we followed in chronological order. So we started with developing an inventory of all the lines using the lane diagrams provided by NTTA and Google Earth imagery. Then we collected the retroreflectivity data using the LLG7 mobile retroreflectometer unit at zero point 0.1 miles intervals. What this means is the unit gives an output file with the RL values averaged at every zero point 0.1 mile. And then, during data collection, we flagged the events like work zones, dirt, debris, water, or any anomalies we found while collection that could affect the performance of the marking temporarily. And then we processed the raw CSV files and converted the odometer readings to stationing for easily identifying the location of that marking. And then we generated the summary tables by line, direction, and for each corridor. This was the main output from the data processing. And then coordinating through VRX, we also obtained information on the marking materials, locations, and installation dates from the NTTA records, and this was used later in data analysis. The table here shows the retroreflectivity condition of pavement markings on all NTTA corridors in 2022. This was the first step for our data analysis. This was to assess the condition in all four categories and to like and to show the results in an easy manner. And second was to develop service lives for all the materials used. This particular graph shows an yellow thermoplastic and these are all the sections where it was used in at the time of data collection in 2022. The x-axis is the age of the marking at the time of testing, and this was obtained through the striping records. And the y-axis is the retroreflectivity. On plotting all these points on the same graph, we were able to develop best fit lines and see where the marking might fail, which is like reaching the low threshold level. So here, this particular type of marking was failing at around 3.7. So in around 3.7 years, we would see that we might need to replace this marking, but we still kept it at 3 years to be conservative. So, following that procedure of developing graphs for all marking types, we came up with this table in year one. From this, you could clearly see that tape was performing the best. And from all the procedures set up, we continued that in year two, but made small improvements. First was we collected the retroreflectivity data at zero point 0.1 mile intervals in 2022, but in 23 we collected it at 0.01 mile interval. This was because we NTTA wanted an average RL value for every 500-foot sections, and having a data point of this granular level can make it easy to average 9 to 10 points and get required retroreflectivity data. And New Age Services developed line features for entire NTTA network with the 500-foot section breaks. We used these line features and averaged our retroreflectivity data by section and summarized it into tables. We also updated the existing degradation curves with additional years data points. We reevaluated the network-wide retroreflectivity condition and service life estimates, and then we performed the comparative analysis. Overall, the service lives of the markings were similar to what we observed in the previous year. This particular slide shows the degradation curves of white thermoplastic marking in 2022 and with added points in 2023. So refining this graph with more data points, especially initial data points within an year, helped estimating the service life better. And now we could say that the marking could last around 5 years, and instead of just 4 years last evaluation. So in year three, we followed the same data collection and processing methods as the previous year, and then we updated the existing summary and condition tables. We integrated the 2024 data into the degradation curves. But the new thing we did in year three is we increased the scope of the project by evaluating capped materials as well. So in simple terms, Capping is installing markings on existing markings. So in NTTA network, they capped the tape and thermoplastic markings at few sections with thermoplastic, and we obtained those sections and developed new degradation curves to evaluate them. Then we estimated the service lives for all the categories. By now, we had enough data for tape and thermoplastic sections to separate the main lanes to direct connects, because the main lanes and frontage roads could have different traffic than direct connects. And we can also see that the service lives on direct connectors are generally higher than on the main lane and frontage road sections. In addition to all this, we also conducted supplemental analysis where we developed new degradation curves at both corridor and corridor segment levels. And then we estimated the end of transition condition service lives for each marking material by roadway facility type, corridor, and segment. So these idea was that these curves would provide insight into potential differences in marking performance under varying traffic volumes, surface type, and other factors in comparison to the network level benchmark that we established in these 3 years. So this is an example showing white tape on all DNT sections, and the graph on the right shows the white tape sections only in the DNT segment 1. And we could see that the tape is deteriorating a little faster in segment 1. So based on this analysis, we developed the service life estimate tables for all main lanes and frontage roads separately, and also for each corridor and each corridor segment. We also separated high volume roadways from low volume roadways, which were the bridge and tunnel sections. From this entire analysis, mostly the markings had similar service life as the network level, but there were a few combinations. By combinations, I mean few marking material, color, and network sections where the difference in the service life was more than more or less higher or lower than 2 years. There were a few potential reasons we identified were, say, on DNT, the yellow edge line was so close to median barrier, so they had a very narrow shoulder, and vehicles would not drive on those markings naturally. That's why they were wearing slowly in comparison to the white markings within same section. Also, in a particular segment of DNT, there was a lot of construction equipment flow, so leading to faster deterioration of the markings there. So, in summary, now NTTA is equipped to develop the annual maintenance striping plans supported by the comprehensive record of marking performance data and analysis. And for any new projects, NTTA could easily evaluate and select the marking materials through quick cost benefit analysis, and to continued evaluation of uh, the degradation curves, and especially supplemental degradation curves, we would be able to improve these service life predictions and support better material comparisons. And with all this baseline established, future annual updates to the payment marking management system could capture more detailed long line attributes from maintenance or new striping, like the manufacturer, product name, striping contractor, the temperature at the time of placement, traffic volume, bead type, thickness of product, etc. Because multiple factors can affect pavement marking performance, and so it's difficult to isolate a single cause for anomalies. However, having as much information as possible for each marking allows us to identify the potential reasons in an informed way using engineering judgment. So, in conclusion, this presentation provided an overview of the marking management work we did for NTTA, but should another agency desire to perform their analysis in a different manner, we can always modify our services. I hope you found the presentation useful. Thank you.
Thank you very much, Leela. You may now begin submitting your questions in the chat box, and Leela will answer as many questions as possible in the time remaining. So we have quite a bit of time today, so we can certainly get to many, many questions. We hope you enjoyed today's presentation and that you will join ARA for future webinars. Our next webinar Wednesday is on July 16th, and the topic is from simulation to mission execution, how VICE, VISC, and MPMS works together to enhance mission success. And that's a very interesting topic, and I hope you join us for that webinar. Our presenters will be Robert Bell Isle and Jeff Himes. We have many more exciting topics in the works, so please watch your email for updates on or visit the Webinar Wednesday webpage, www.ara.com/webinar. Let's get to the Q&A portion, and we have a few questions coming in, and I'm going to kind of paraphrase some of these questions, Leela. So the first question is from Rishi Adhikari, who says, were pavement surface milled and then thermoplastic and tapes applied into that milled portion, or were they just placed directly on top of the pavement surface in your study?
So I think the pavement surface was milled before installations. I'm not entirely sure for the capped sections, but for the other ones, they normally mill it.
Thank you. The question from Radha, when the low retroreflectivity markings were replaced, could drivers drive with that low amount of retroreflectivity?
So just to clarify, after replacing, or
I'm assuming this is, when it gets pretty low in some of your numbers, were drivers still able to, or did you have any negative effects of that? Or I guess that's what the question is asking.
So yes, drivers did continue driving on those roads and using the toll road network. But as you know, it might be okay during the day, because if the marking is still present, if it's completely worn, it's a hazard even during the day. But if it's still present, intact, the drivers might get away during the day, but at nights it is hard.
All right, thank you. Dan D'Angelo wants to know what drove the need for pavement marking management system at NTTA in the first place, and how did you address, or what were the specific needs, and how did that shape your approach towards this task?
So, NTTA want, as we discussed in our goals, NTTA wanted to know how their markings were performing for their maintenance needs. And also, currently, they have a system of replacing the markings at fixed schedules, and they wanted to verify the service lives that they assumed that they would get for that particular marking material. And also, for the second question on how we shaped our approach, so the basics still remains the same of testing the markings and processing them, and measuring it against the threshold values. But say in the second year, we changed our intervals to 0.01 miles. So small things like that we incorporated along the process.
Well, thank you for that answer. There's a question from Manoj that's asking, what was the thickness of thermoplastic material? And did you consider including wear on that material as part of ASTM D913 in the study?
So I think the thickness was around 100 mils for the thermoplastic markings, and around 60 for the capping. We exactly did not um, dive into the wear of specific markings in terms of like the chemicals side of it. But overall, we were looking more into um, if the beads were still reflective.
So Rob wants to know, did NTTA consider using a different spec or stripe that could last a few years longer? And I'm not sure if he's referring to different than what you already have or different than after you concluded your conclusions. So if you could address both of those, that would be useful.
Sure. Um, as far as I know, they do not have intentions to change the marking type immediately, but I would not be a correct person to say that, because I wouldn't know anything about their maintenance plans. But in the 3 years that we did the project, there weren't any change in the marking types.
Okay, thank you. Salsa wants to know, does the pavement markings testing include on concrete, and how do you see the performance difference on asphalt? And I guess there's another question here. What's better in terms of performance, concrete or asphalt for the marking?
So we did not change evaluate the markings based on the pavement type. When we did the testing, those markings were on both asphalt and pavement, but in our analysis we did not look more deep into it. I'm sorry.
Okay, no problem. And there's a comment from John that basically says thermoplastic striping normally requires recessing in the pavement by milling. I guess that doesn't necessarily apply to paint, but the striping typically does. I think there was a follow-on question on one of your answers, so let me go to that. It sounds like this, you answered this, but let me read this question. Did your study have any sections of roads with regular pavement marking paints? If yes, how was the performance? I think you covered that, but I'll give you a chance to answer.
So if they meant by the waterbound or solvent paints, no, we did not have any sections with that in this study.
Okay, thank you. I think Dan is a follow-up question for agencies looking to develop a pavement marking management system. What key steps would you recommend to get started?
So I think the first step would be to identifying their markings. So I'm developing an inventory for their longitudinal markings, their limits, or like extents on the network, and maybe even for the center of lane markings. I would say that's the first step, and from there they could go forward with either doing the pavement marking testing to for the entire network or a sample sections, and then go forward with adding the installation records and so on and so forth.
Thank you. Robert Cochrane had this question, and this is related to the answer you just provided. Did NTTA already have a system-wide process for measuring retroreflectivity in place before the study, or was this the first time that this process was undertaken at NTTA? And then were all roads as part of the network measured for this study?
As far as I know, this was the first time